Well, what I'm going to talk about today is the report that we launched this week, which was headed up by the Joint Mathematical Council of the UK. There were a number of us who were in that working group, including Alison and Adrian, who spoke earlier this morning. So the working group was underpinned by the idea that we're not providing the types of engineers and scientists and entrepreneurs that we need for the 21st century. So we wanted to look into how we could make recommendations about how the maths curriculum and how the mathematical experiences of young people in schools could change so that they would develop the skills which we believe are needed by society. So underpinning the whole idea was how to inspire and develop the next generation of innovators, creators, scientists, technologists, engineers, and mathematicians, on which our future well-being and economy depends. Now, what we have reported on, and the working group actually consisted of mathematicians, maths educators, mathematical engineers, and computer scientists. And what we've actually identified in this report is that whereas mathematicians and engineers are creatively and constructively using mathematical digital tools in the workplace, and whereas young people, we know, and we do have the evidence for this, are creatively and constructively using digital tools out of school in order to produce things which they value, we also know that young people are very unlikely to be using digital mathematical tools outside school. So what they're doing outside school is not likely to be helping them to learn to use mathematical digital tools creatively. We also know from research and Ofsted reports that in schools, young people are not using digital mathematical tools creatively and constructively. And in fact, we know that the majority of what goes on in maths classrooms is either the use of the interactive whiteboard for demonstration or the use of computer-aided learning programs to help children get through their GCSEs. Now, I'm not arguing, actually, that that's not important. I do believe that that is very important. But what is also important is that young people get the opportunity through school, which we believe is the only place they will get it for the majority, to use digital mathematical technologies constructively and creatively to produce mathematics. So, overall, we've made a number of recommendations, and Alison spoke to the one on professional development this morning, so I'm not going to repeat that. But we actually believe that it is the high-stakes assessment that's got in the way and is inhibiting teachers from using these creative digital mathematical technologies in the classroom. So we've made a recommendation which says that curriculum and assessment in school mathematics should explicitly require that all young people become proficient in using digital technologies for mathematical purposes. We've also made a recommendation that says that high-stakes assessment needs to change in order to encourage the creative use of digital technologies in mathematics classes in schools and colleges. And finally, probably the most important recommendation, which we hope will enable us to take things forward, and I do take what you said in your previous talk, and we need to take that into account in this current climate, but we've said that the UK Departments for Education and for Business, Innovation and Skills should establish a task force to take the lead in bringing together various parties with appropriate expertise to take forward the recommendations of this report and advise the departments on required policy initiatives. So we think there's a space to be doing some work now. I think you've all got copies of this report, and the full report is on the website. And so we would like to discuss with you some of those recommendations, and in particular the last recommendation. Thank you.
Thank you very much.